So, welcome back. We had just seen that after referring to table 1, how did we decide in which zone the given state lies. Let us refer to table 2 because the same exercise can be done by using table 2. Earlier we had used table 1. So, this slide now will understand if I were to use table 2, how do I identify different zones for a given state. So, again I will go back to PT diagram here, and now I have been given PT value over here, alright. So, given PT, now because I am referring to table 2, my reference point becomes P now, pressure, and corresponding to this given pressure, I will get the value of T sat P now, isn't it? For a given P, I will go to table 2, locate that value of P and get correspondingly the T sat P value for that pressure. The find T sat P, and the first case again, if this T happens to be T sat P, the given T value is equal to T sat P. If that is possible, then I know that our system lies on a saturation line, as was the case with table 1 when the pressure was equal to P sat T. Here the first case is referring to temperature is equal to T sat P. If that is possible, that means this state lies on saturation line, LV saturation line. It also means that the given point is nothing but P sat T and T sat P, alright. The coordinates of these points are respective saturated pressures and temperatures. The second case, now I am comparing temperature here, and if this temperature happens to be more than the T sat P value over here. So, in case my T is more than T sat P, the state lies in a superheated vapor zone as shown over here. So, second case, if T is more than T sat P, the state lies in superheated vapor zone, alright. Now, the third case is if temperature is less than T sat P, then obviously the state lies in a subcooled or compressed liquid zone. I think it is very simple to understand from here now. I am just comparing temperature with the T sat P value. And the fourth case is the same case as what we had seen earlier. If the pressure and temperatures are beyond the critical limits, so T is more than T critical and if P is more than P critical, then the system lies in a supercritical fluid zone, or the state is in a supercritical fluid zone as shown over here. Thus, by using table 2 now and by comparing temperature T sat P with given temperature, we can identify that given state lies in which zone. Of all these 4 zones, we can find out in which zone it lies. So, in summary, I can show that from table 1 I can compare the pressure for a given temperature, and from table 2 I compare the temperatures for a given pressure. So, T sat is the given value, and compare T with this T sat and compare P with this P sat. So, these 2 tables actually is summary of what we saw just now by referring to table 1 and table 2 in order to decide a particular state lies in which zone. So, what have we learned? We have seen that how to identify a given thermodynamic state in which zone it belongs to on a PT diagram. We have seen that zones on PT diagram by referring to table 1, we compare the value of pressure with P sat, and in table 2 we compare the value of T with T sat. Thank you very much.